This short video is to show you how to wire components for connection to a microbit. So one of the great things about the microbit, it was designed for physical computing. That means for sensing, coding and robotics projects. And if you're going to do that, at some point you're going to have to connect electrical components or electronic components like this LED to the microbit. You can in fact connect them directly to the brass edge strip along the bottom of the microbit, but you'd normally want your component built into a model or some distance from the microbit, and therefore by wiring the component you can then have the component some distance away from the microbit, and these wires can be extended and made as long as you like. So what this video is to show is how you connect the wires to the components with a secure connection. The tools you'll need are very simple. I've got a soldering iron here. I've got a wire stripper to strip the insulation. I've got a pair of scissors, you don't need pliers or anything, and a ruler, and also some solder. And that's all you need. So the first thing to do is to get hold of some multi-strand wire like this. It's just thin multi-strand wire used for making connections in circuits. Multi-strand means that it's flexible, it's much nicer to use, much easier to use than single-strand wire. And I've got black and red. The reason for that is I'm wiring a component that has polarity. An LED has polarity. That means that the current has to flow through it in the correct direction. It has a positive side or leg, that's the longer wire here, and a negative leg, the shorter wire here. So you know that that needs to go to the positive wire. So it's traditional that the red wire is positive. So I'm going to cut off about 15 centimeters of red wire, and then using my wire stripping screwdriver, it's got a 3mm screwdriver at that end and a wire stripper at this end, push the wire through, push it up, and then just pull the wire, and that's stripped off the insulation. And you'll need to do both ends because both ends will be connected into the circuit. One of the problems with multi-strand wires, these strands tend to splay out a bit like that, but if you twist them together, it makes for a much neater connection when you solder the wire. So I just twist it like that, and you've got a nice twisted end to the wire. So that's my positive wire. I've done a negative one in the same way earlier. Now when soldering these wires to the component, you really need 3 hands. So what I do is I use some masking tape and I tape the component down. The reason I'm using this board here is because it's a heat-proof mat, and this soldering iron, this end of the soldering iron gets very, very hot indeed. So when you're using it, be very careful. If you're allowing learners to use a soldering iron, they must be taught safe practice first. Now, the wire is also taped down just to hold it in place. So there's my red wire on the long positive leg. If you're using the component for higher voltages, say 6 volts, if you've got a robotics board and you want to put an LED on that, then you have to put a protecting resistor between your positive leg and your wire. This is a 300 ohm resistor. It stops the LED burning out. But I'm only going to use this component on a microbit, so 3 volts is fine. It doesn't need a protecting resistor. So I'm going to go straight from the positive leg to my red wire, tape that down, and then my negative black wire, and tape that down. And so I'm now ready to solder. Soldering, tricky at first, but with practice you get better and better at it. So what I do is I turn the soldering iron on, leave it on for about 5 minutes, and it will heat up. And then when I come to solder, I don't put the solder onto the soldering iron. I use the soldering iron to heat the two wires by pressing gently on the point where the two wires are next to each other and let that heat up. You want lots of heat in there so that when you do bring the solder up to the two wires, the solder will be melted by the wires rather than the soldering iron. In fact, what I do is I tend to bring it up to the point where the soldering iron touches the wires, and then if the wires are hot enough, as the solder melts, and it'll be left a little bit longer, as the solder melts, it will run along the junction between the two wires. I'm being a bit impatient. And that will give you a nice, secure, you might need to add a bit more solder. That will give you a nice, secure join. A bit more solder. You don't have too much solder, because if you get blobs of solder, it causes problems later on. So I'm rushing it a bit. You really need to get the wires quite hot. You don't want to overheat them because you might then damage the component. Some components are much more delicate. You have to be a bit more careful. So I'm getting my heat into the two wires. Let's try that. That's better. I left it a bit longer that time. You can see how the solder flows along. Leave it a minute, doesn't take long. The solder will set and you'll get a nice secure electrical connection between two wires and the component. So now the problem is short circuit. If these two wires touch when it's in a circuit, a live circuit, you'll get a short circuit. So we need to insulate them. One simple way of insulating them is to simply put some masking tape around them, fold it back on itself, do the same the other side, and then you can tie them together with some more masking tape. And that's pretty good, but it's not the neatest way. The neatest way to do it is to buy some shrink wrap. This is shrink wrap. Cut some shrink wrap to the right length, and then use the heat from your soldering iron to shrink that down onto the connection between the two components, between the component and the connecting wire, and then use the heat from the soldering iron just to shrink that into place. And what happens is then that grips quite tightly. Then another piece of shrink wrap cut for the other side and shrink that into place. And then you can have a third piece of shrink wrap, a slightly wider shrink wrap, to hold both of the wires together, and that makes for an even neater connection. So the shrink wrap, you can buy it at the same place you get the components. Comes in different colors. It doesn't really matter what color you use. Maybe I should have used red and black shrink wrap on here, but you can see the wire color easily enough. And then with a final piece, I'm going to make it a little bit longer just to make a really neat connection. The final piece goes around both of those, and then you heat that into place, and you've got your finished wired component. That's it. In the previous video, I showed you how to wire components like this to some wires for connection to the microbit. So this video is to show you how to make those connections. Make sure that the wires are neat. So what I do is I twist the ends of the wires together, and then you simply decide from your code which wire needs to go to which. So if I'm switching this red LED with pin 0, then I need to connect it to pin 0. And the LED goes between the pin and ground or negative. So that's simple. I know that the black wire needs to go to ground and the red wire to pin 0. When you're wiring the components to the microbit, there's two standard ways of doing it. One of the ways we used to do it was to use a crocodile clip to crocodile clip like lead like this. The crocodile clips are insulated so that they don't touch each other and create a short circuit. To connect the crocodile clip, you don't click it onto the edge strip on the microbit like this because it easily slides off. What you do is you open the jaws of the crocodile clip, and then at right angles to the microbit you push one jaw through the hole and the other one grips the bottom edge of the edge strip, and that makes quite a secure connection and also leaves space for another crocodile clip to be connected next to that one. The problem with this is that you get a lot of extra wire in your circuit, and that can become quite confusing. So the preferred method of doing this is to use these tiny little micro pegs. Sometimes they're coloured. They don't have to be coloured. Doesn't matter what colour they are really. But if you have got coloured ones, it's quite nice to use the colour. So for example, if I'm going to connect the red LED to pin 0, then I would use the red micro peg. And that just reminds me which component is connected to that pin. Starting with the ground, you push the bare end of the wire, so you strip the insulation off, you push it through the hole, about halfway along the insulation, where the insulation has been removed, so about halfway along the bare wire, and you can see it's poking out the back, and so it's hooked onto the pin hole. And then you take the peg and you push it through the hole, just push it in firmly until it grips. So that negative wire is now connected to ground. Then you repeat the process with the positive wire to pin 0, push it about halfway along the uninsulated wire, hook it over, just press it, fold it over really, and then I'm going to use the red peg because it's the red component, and then press that in. So that component is now wired. If I want to connect another component, say I want a green LED connected to, say, pin 2, then I'm going to push the positive wire through pin 2, about halfway along the uninsulated end of the wire, push in my green peg. But now I've got a problem. This has to go into ground, and there's already a wire in ground. Actually, it's not a problem at all. You just push the peg out by pushing from the back of the microbit. Put your second wire in, fold that over. So I've now got two wires on my ground pin, and then push the peg in, and that will grip both of them. So that's how to use these micro pegs to connect wires to a microbit. But if you haven't got micro pegs, you can use the crocodile to crocodile clip leads. But I've also heard of people who haven't got micro pegs actually making their own, just making their own with a little bit of wood or something, and just jamming the wire in with a little bit of wood. So just be inventive if you're stuck. And that's it.